Functions of random variables. Okay, so let's talk a little bit more about these guys. Oftentimes, what we're mostly interested in applications or even in theory is functions of random variables. Here's an example. Let's let D sub I denote the demand for a product. On day I. And let's let N sub I denote the amount of type I left in inventory or on the shelf at end of day I. Now suppose that you begin the week, let's say, with let's say at the end of day 0, you have suppose at the end of day 0 you have a fixed number. You know how many items you have at the end of day 0. Then maybe you're interested in knowing the distribution of the amount of items that you have left in inventory at the end of the 5th day, because maybe you've got to place an order at the end of day 0 that arrives at the end of the 5th day or something. So you're interested in the random behavior of this guy, right? This is a random variable. It's going to depend on how much you started with and then how much demand you had, right? I think you could write it like this. It would be the maximum of 0 and N naught minus D1 minus D2 minus D3 minus D4 minus D5, right? Or the max of 0 with N naught minus the sum of DI. I goes from 1 to 5, right? Yeah, because if you have more demand than you have product, then you can't go below 0 in that case. Yeah, so this kind of thing is important. We'd like to know the behavior of N sub 5 in this case, or the distribution of N sub 5. As another example, if you take in statistics, we might say that Y bar defined to be the average of these guys, the sample mean. This is a function of these random variables. This is probably a good estimator for some overall mean mu. And in fact, it is. It has several nice properties that you study in a math stats class. They're all in your book in later chapters. But for one, it's biased. It's unbiased. We already proved that, right? That the expected value of Y bar is, in fact, the population mean. Okay. Let's take a look at another example, a more in-depth example. So let's say that a refinery produces a certain amount of sugar each day. We'll say amount of sugar produced is Y, okay, in tons or ounces or whatever it is. And let's say this amount is known to depend on machine breakdowns, temperature, how late people are, etc., right? And so suppose that Y has the PDF. We know that the probability density function for Y is known to be approximately or exactly 2Y times the indicator that Y is between 0 and 1. Okay? That is, it looks like this. All right. You got to make that noise when you draw these pictures, by the way. Okay. Okay, so that's a density function. That's a density function. If I integrate that, I certainly get 1, right? Because that's 1, that's 2. Here's my y-axis. Okay. All right. So let's suppose further that the company is paid $300 per ton. And you know what, I better stipulate that y is in tons up here so that we make sure that we do everything all right. The company's paid $300 per ton, but has an overhead cost, like machine setup costs and all that, of $100 per day. Overhead cost of $100 per day. Then what you're really interested in is the daily profit, okay? Daily profit, maybe we'll call U, okay? Okay, so U is defined to be, well, let's see, it's going to be 3y minus 1. Did you write it like that? Yeah, I guess you could think of it like that. So you know, it's I guess the units on U are in $100 bills or something like that. Okay, so just do it this way so that we don't have to write all the zeros all over the place. So in $100 bills. Okay. So let's find the probability density function for U. Find f sub u of u. Okay, that's what that is. The probability density function for u. Well, first we start by finding the CDF for u. So, and that's not hard, because remember, by definition, actually this thing is just the probability that u is less or equal to little u, right? That's what that means. This is the probability that our profit is less or equal to this number, whatever that is. And at this point, I'm just going to sub in what u is. What u is, right? That's the probability. Whoops. And by u, I mean big U. Okay. It's just the probability that 3y minus 1 is less or equal to little u, right? See that? Pretty easy. Now I'm just going to solve this this little inequality for y. I'm going to get y over there by itself because I know, let's see, how do you do that? It's going to be little u plus 1 over 3, right? So y is less or equal to little u plus 1 over 3, right? Yeah. Okay. So and this is for little u in -1 up to 2, right? Because if you put in, and y is somewhere between 0 and 1, y takes a value between 0 and 1. So if you this is linear, so if I put in 0, I get -1. If I put in a 1 in for y, I get 2. Okay. All right. So, and then, yeah. All right. So. So our distribution function for u then is going to be, remember, it's going to be 0 for u less or equal to 1. It'll be 1 for u greater than or equal to 2, and then And then, oops, sorry, this should be -1. And then for in between -1 and 2, it's going to be the same as the probability of y being less or equal to u plus 1 over 3, right? So I've got the CDF of u being expressed as a probability statement about the random variable y. Now, what is this? I know how to get this. It's simple. It's an integral, right? From -infinity up to this mark, u plus 1 over 3, of the density function for y. Okay? So at this point, I'm just going to deal with this. I need to get an expression for this stuff, so I'm just going to work with this. Okay? So the integral there of the density function for y, dy, is, let's see, what was that guy? The integrand there. Just 1 over 3. The integrand was, looking for it over here. Oh, it's 2y times the indicator of little y being between 0 and 1, dy. Okay? So then I can get rid of this indicator function and just integrate from 0 to u plus 1 over 3, right? 2y dy, right? This is for y between, I'm sorry, for u between -1 and 2, right? Again, just, yeah, I should probably put that up here. U between -1 and 2, okay? Good. Okay, so that's carried out easily enough. Comes out to be, I think it's squared over 2, it's just u plus 1 over 3 quantity squared, right? Okay, good. So now I have the CDF for u. I can differentiate the CDF to get the PDF, right? So f sub u of u is just ddu of f sub u, big F sub u of u, okay? In that region, that is in for u in -1 to 2, just work with that region there. It's going to be ddu of u plus 1 over 3 quantity squared, right? Okay, and then, so this is, what, 2 comes down, and then times u plus 1 over 3 times the derivative of the inside. So 2/3, so it's 2/9 times u plus 1, okay? And again, so that's for u in -1 to 2. So, and I know it's going to be 0 elsewhere, right? So the density function for u, I can just write like this maybe. It's 2/9 times u plus 1 for u between -1 and 2, and 0 otherwise. Okay.